Hi students, this is Miss Medina and I'm going to do a quick review of rational irrational numbers since I couldn't find the video when we did this in class. Rational, irrational. First of all, you need to be able to identify whether you have a rational or irrational number, and that means you have to be able to sort your real numbers like this. So your integers, negative, 0, 1, ratios, fractions, repeating decimals, terminating decimals, and the square roots of perfect squares. All of that is going to be rational. And then your irrationals, your famous irrationals like pi and numbers that never repeat and never terminates. How are you supposed to know? Well, if you have the three dots, that means they don't end. And the fact that the 3, 7, and 4 don't repeat tells you that it's a non-repeating, non-ending number, irrational. And the square roots of non-perfect squares, that's also going to be irrational. All right, so for example here, very quickly, let's see if we can identify these numbers. Negative 12, r, square root of 6, I. Why? Because 6 is not a perfect square. 2 over 3, r. Square root of 25, r, because that equals 5, it's a perfect square. Pi over pi cancels out and you get a 1. 1 is r. Radical 3 over radical 3, same deal. It cancels, you get a 1, so it's r. This doesn't cancel for g, but they're both perfect squares, right? So you get 9 over 10, and that's r. And this one, same deal. They don't cancel, but they're perfect squares. So you get r, right? You're going to get 2 over 5, which is rational. Now, when you have operations between two rational numbers, right? I'm talking about over here. Irregardless, it's going to be rational. Now, the only exception to this would be you cannot divide by a 0. Okay. If you have an operation between a rational and an irrational, and it doesn't matter who comes first, but they're both going to be irrational. The only exception would be if your rational number is 0, because multiplying by 0 is going to give you 0, which is rational. And if 0 divided by any number is going to be 0, which is rational. So those are the only two exceptions where you won't get an I, you'll get an R. And obviously 0 is involved. All right, now if you have two irrational numbers, then you're not going to have a choice. You're going to have to do the math, right? Because the answer can be I or the answer can be R. Now it cannot be both, it can only be one of them, which is why you need to figure out what it is. So for example here, let me zoom in, right? 5 over 3 is R, and radical 2 over 10 is I. And when you multiply one of each, you're going to get I. 1 over 3 is R, 9 is R, so when you add them, you're always going to get R. Now this one right here can be tricky because you're saying, well, this is I, and I'm multiplying this with I. Well, shouldn't I get I? Well, not so quickly. Remember, when you have two i's, you actually have to think about the math. And this gives you the square root of 49. 49 is a beautiful, perfect square, which gives you 7, and 7 is pretty R. So this is a case where two i's actually give you an R. Pi times 2, this one is I. Multiplying by R, this one always gives you I. I'm writing with my mouse, that's why it looks weird. Pi minus pi is, once again, you're thinking, oh, pi, definitely I. Well, actually, no. Stop and think. Any number subtracted from itself is going to give you 0, and 0 is pretty R. And same thing with F, right? We know both of these are I's, right? You're thinking, oh, they're all I's, it's going to be I. Not really. Think about it. Any number divided by itself is 1, which would be R, okay? So always stop and think. Don't just assume that because they're both I, you're going to get I. Stop and think, because sometimes you get an R. Okie dokie. And I think that's it. This is the review that we did for the unit test, okay?